start counting the objects, like they have number of pencils or apples or something like that, or books. They'll start counting like 1 pencil, 2 pencils, or 3 pencils, or 1 apple, 2 apples, 3 apples, and so on. They'll be counting in this manner, and there are so many ways they'll count in daily life. So children will be very interesting that they have started counting. So in that, counting numbers 1, 2, 3, 4, 5, these all together are called as counting numbers. So 1, 2, 3, 4, 5 are counting numbers, and these counting numbers are naturally called as natural numbers, because these are counting. Generally we start counting with 1, all the numbers. That's the reason these numbers will be called as natural numbers. So natural numbers are starting. We are starting the counting with 1. That's the reason these are natural numbers, and we know that we start counting from 1 and we'll continue the counting till what we get. Nothing is number, the digits or objects, but here the counting will not end at all till infinite. That is uncountable. We will not stop the counting. So that we know it. So 1, 2, 3, 4, 5, 6, 7, 8, 200, billions and trillions. This will continue when we add 1 to the particular number, and then extends to next number. So this will not end. The counting will not end. That's the reason these are not ending at all. So these numbers are natural numbers, and this will be denoted by just normal brackets, or also we can use 1, 2, 3, 4, 5, and so on. Using the braces or flower brackets we can use, and these natural numbers are denoted with a capital letter N. So these are the natural numbers. Now let's see one of the example. Suppose one student has 3 chocolates. So he took that 3 chocolates and distributed to 2 students, 2 friends. So the 2 students ate their chocolate after taking it from him. So, and one of the chocolate is left out, and he also ate that chocolate. So from 3 chocolates, all the 3 chocolates are completed. So what we get is, we don't have any chocolates with us. That is, nothing is left over. So 3 chocolates, and then they ate the 3 chocolates, and they have completed all the 3 chocolates. Then they don't have any chocolates. That is nothing but we call 0. They don't have any chocolates. We will represent as 0. So here we got the 0, but we did not count that one as a number, because we'll start counting from 1. So we doesn't require that we start from 0. So here 0 is a number. So 3 minus 3 chocolates we ate. So we got 3 chocolates and we ate. We don't have anything. So we don't have anything. That is nothing. Nothing is 0. So 3 minus 3 is 0. So along with this natural numbers 1, 2, 3, 4, 5, and so on. We combine these natural numbers along with 0. Then we call these numbers as whole numbers. These are whole numbers. So whole numbers are denoted by capital W. So this also can be represented in the brackets that are braces. Also we can use a normal bracket. So these are have learned about the numbers, natural numbers and the whole numbers. Let's see the next concept. Let me start counting. When we start the counting, like 0, 1, 2, 3 and so on, there is a particular order, like there is a difference between the two numbers is same, always same, because you see, just you can look at these numbers, there is a difference between these two numbers is always same, and the difference between these two numbers is same and so on. We can see that. So let's take first number 1 on the on one of the line. We have taken a line. So just we have learned in geometry part. So the set of points on a line which extends on the both sides, on the both directions, we call it is a line. So we have drawn a line and just place 1 on this number on the line. So number we have taken 1. So next one, the distance is equal between these 2 points. We will take it as 2. The distance between these 2 is equal because 2 minus 1 is 1. Then we will take it as 3 and 4, 5 and 6 and so on. And this will not add at all. So this is called as number line. So up to now we have learned about the natural numbers and number line. This is we use the natural number line for this. So let's go to the concept of properties of whole numbers. Properties of whole numbers. Properties of whole numbers. And just before we have learned about the whole numbers. Whole numbers are 0, 1, 2, 3 and so on. 0, 1, 2, 3 and so on. These are denoted by capital W. So let's see. We'll take one of the whole number and test properties of whole numbers. Let's see. First, addition. Addition rule. Property on addition. Then let us take any two numbers here. Choose any two numbers from the whole numbers 1 and 2. After taking 1 and 2, just we combine with addition symbol because the first we are using the addition here. So add these two numbers and we get the sum is 3. So 1 plus 2 is 3. And then take any other number from the whole numbers 0 and 3 is equal to 3. Here normally we have taken some of the whole numbers like 3 and 5 is equals to 8 and 7 plus 2 is 9. And what we observe from here is we taken two whole numbers and we added them and we got a whole number. So this is known as one of the rule, that is closure property. Closure property. Closure property is nothing but when we take any two whole numbers and add them, we get a whole number. Two whole numbers are added and get a solution of whole number, and we get a whole number. Then that property is called as closure property. Let's go to the properties of whole numbers. Properties of addition. Let's see some of the properties. We take any two whole numbers. Let's take any two whole numbers. 1 and 2. We add these two whole numbers. We get 3. We taken two whole numbers and added them. And we got a whole number. Then this property is known as closure property. So closure property of addition. We are doing properties on addition. So And then after adding these two whole numbers, let's change this order 1 and 2. Let's change this order of it and 2 and 1. So let's see what is the sum of these two orders. Is 3 and 3. So both the sum is equal when we take in two whole numbers and adding them. Then when we change their orders, 1 in the place of 1 we have taken 2, in the place of 2 we have taken 1. And after that we found the sum of it, and this sum is equal, and this property is known as commutative property. This commutative property, we are doing the operation on addition. So commutative property under addition. So commute is nothing but it's moving around. So moving around is called as commute. So we are moving the places of 1 and 2. So 1 plus 2 is 2 plus 1. So let's go to the next concept. Associative. Associative property. Let's take like 3 numbers 1, 2, 3, and let's take a group of 2 numbers from this 3. We have taken a group of numbers, group of 2 numbers from this 3. So 1 and 2 as a group. So add them. So 1 plus 2 is a group and 3 is separate. And similarly, take 1, 2, 3. Now, before that, we have taken 1 and 2 as a group. Let's take 2 and 3 as a group. First time 1 and 2, second time 2 and 3. So as the groups we have taken, let's find out what is the sum of it. 1 plus 2 is 3, 3 plus 3 is 6. So 1 plus 2 plus 3 is 5. So 1 plus 5 is 6. So on both the sides we are getting the same result. So this is called as associative property. So associative property of addition of whole numbers is same. So it's possible. Let's see addition property of identity rule. The rule of identity of addition is nothing but you take any one of the number, you take a whole number, add a 0 to that number, and you'll be getting the same number. So this is nothing but identity. We call identity is nothing but reflecting something. You get the same result, you get the same value, or they get the same. So we call that as identity. So we take any one of the whole number, for example, it's 2, add a 0 to it, we get the same result what we have taken. It's 2, so 2 plus 0 is 2. So 0 is called as additive identity. Another example, 0 plus 3 is also 3, and 5 plus 0 is 5. So take any whole number